Okay, so the time would be v naught sine of theta plus square root of v naught squared sine squared of theta plus 2vh, the whole thing over g. And so why don't you go ahead and figure out what that is? Try it. You got it?
It's the sine of 30, or the sine of theta under the square root is squared, right?
Yes. What's it?
But the velocity is also going to be squared.
Yep.
Yeah.
In there. As a rule of thumb, it's usually I don't know. It's usually easiest to like evaluate that and then add, and then divide. So,
So I'm just using meters per second.
yes, 3 meters per second for the initial velocity v naught, initial speed v naught. Yeah, Bryce?
I got it as 0.69 seconds.
Yeah, that's what I got.
0.69 seconds. Okay, good. So that's my initial, or that's the time it takes to hit the ground. Let's see how far it traveled in the x direction in that time. So I'm just going to plug it into this equation, assuming that x naught is equal to 0. So the range would be v naught x, which is v naught cosine of theta, times that time.
So,
So what would that be? Is that what you get, 128 meters?
yeah.
So you just plug in 3 meters per second, cosine of 30 degrees, square root of 3 over 2, times that 0.69 seconds. All right, there's your range. You know, that's what we're looking for. There are other questions you can ask too. One question that is fairly standard is, okay, how far above, what's the maximum height above the ground that this thing was at? H max. How did you get that?
The average?
No, the maximum height.
Oh, maximum. When acceleration equals 0.
Oh, I know.
Acceleration will always be g when it's in negative.
You can divide, can't you just divide the range by 2 and then?
No, you could have done that if you started out here.
Well, you could,
But if you started
Oh,
out
yeah.
at an angle here, this
Higher.
maximum height isn't at half the range.
sure.
Started out at a height.
So y velocity equals
So what's the condition to be at its maximum height?
The y velocity is 0.
Y velocity is 0.
Mhm.
So let's figure out the time when the y velocity is 0. So what you could do to do that is, we know that the velocity in the y direction is any time is the initial velocity in the y direction plus the acceleration in the y direction times time.
Is that a 1?
Set of
dy
one.
over?
At any time.
Oh, okay.
Okay? Well, the acceleration in the y direction, if we're just being acted on by gravity, is minus gt, is minus g. So to put that, that's my velocity in the y direction. Set that equal to 0 for maximum height. So 0, velocity in the y direction minus gt. The t would be v naught y over g. You can check me on that. If I just plug this t into here, I'd see that that would happen. All right, this would be the time when it's at its maximum height. If I want to figure out how high above the ground was it, what should I do?
Plug that in over
Times the v.
Which equation should I plug it into?
the second one. No?
That would tell me how
Oh, that's the
far it's
extra-
traveling.
the
The
first
extra
one.
action is that time.
Yeah, sorry. The position, so you can find the y.
Yeah, I'd want to take that time and plug it into the y position if I were interested in the maximum height.
Yeah. No, never mind.
Does that make sense?
Yeah.
So are we figuring out y in terms of t, the first?
Yes. So you take y is equal to h plus, initial velocity in the y direction times that time, minus 1/2 v times t squared, which would be g squared, minus sign here. This and this look the same. That would actually be y max, or h. This should be the height max at this point. So I get h max is the initial height. These two combine, so this is v naught squared over g minus 1/2 v naught squared over g. Cancel out one of those. And so that'd be h plus 1/2 v naught y squared over g. You can plug in numbers for that. So that's for the range, almost always you just look at where it hit the time when it hits the ground, plug that into the x equation. There are other questions you could ask where you might want to do some other stuff, like figure out the time and then plug it into the y equation for if you're interested in like a maximum height. Okay. All right, I will let you guys go.
How long will you be here